Today we're going to be working with solving one variable linear inequalities. So you should be looking at N1-2. Okay, I want you to go ahead and highlight this first sentence. This is very important. It says, remember when you're multiplying or dividing by a negative number, you must reverse the inequality. So I'm actually going to end up changing the direction of my inequality whenever I multiply or divide by a negative. Now, if we're going to look at the first few examples, you are going to solve the inequality exactly how we solved the equation the other day. The only difference is instead of an equal sign, I'm going to have an inequality. So less than, greater than, less than or equal to, or greater than or equal to. So let's first start at problem number 1. I have 3x minus 2 is less than or equal to 5x minus 3. So it tells me I'm going to solve the inequality and graph the solution. Okay, so in problem number 1, I'm going to add 2 to both sides. Gives me 3x is less than or equal to 5x minus 1. And then I'm going to subtract 5x from both sides. So again, I haven't done anything differently. We're still solving our equations the same. So here I end up with a negative 2x is less than or equal to a negative 1. Now I'm going to divide both sides by a negative 2. And remember, if we divide by a negative, I'm going to change the direction of my inequality. So here it was less than or equal to. So when I rewrite it, I'm going to have that x is greater than or equal to 1/2. So again, notice how I changed the direction of my inequality. Now it's going to ask you to graph. So here's how I want you to graph. My answer ended up being x is greater than or equal to 1/2. So here's how I want you to do it. We're going to label 0 on every graph. Then I label my 1/2. Now remember, if I have the equal to sign underneath my inequality, so this line right here, I'm going to have a closed circle. That means it was included. So here my circle is going to be closed, and since it says it's greater than, I'm going to draw my arrow to the right because that's where my positive numbers are getting bigger. Okay, so let's look at problem number 2. Here I have 4 minus 2x is greater than 6. So here I'm going to subtract 4 from both sides. I'll have a negative 2x is greater than 2. Again, we're dividing by a negative 2. So what happens? That's right, I'm going to change the sign of my inequality. So here instead of x is greater than negative 1, I really should have that x is less than negative 1. And again, I said we were going to graph it. We must have the 0 labeled on the graph. And I'm going to have my negative 1. And since it's just less than and it's not equal to, I'm actually going to have an open circle. And my arrow will go to the left towards my negative values. So looking at problem 3 and 4, you guys should be able to work those examples. I want you to go ahead and attempt those examples along with the graphs, and we'll check them in class tomorrow. Now turn the page and we're going to talk about conjunction and disjunction. A conjunction is considered an and statement. So if you look at problem number 5, this is going to be an example of a conjunction. Okay, here I'm still going to solve my equation the exact same way, but whatever I do to the middle, I must also do the same thing to both the left and the right-hand side of the equation. So looking at problem number 5, I have negative 5 is less than 2x plus 3, which is less than 15. So again, we're trying to solve for x. So in order to get x by itself, the first thing I need to do is subtract 3. Now instead of doing it from both sides, I'm actually going to subtract 3 from all 3 sides. So when I subtract 3 from each side, I end up with a negative 8 is less than 2x, which is less than 12. Okay, and now I'm going to divide everything by 2. Again, whatever I do to the middle, I must do to the left and the right-hand side. So look at where my answer ends up. I have negative 4 is less than x, which is less than 6. So this is your answer for the conjunction on problem number 5. Now let's go over again how to graph it. Remember I said we're going to start with the 0, and now we have 2 answers, so I'm going to graph both of those on the number line as well. Putting both negative 4 and 6 on my graph, since my answer was both less than, both of my circles are going to be open, and they're going to be included between the 2 dots. So I'm going to go ahead and shade those. You can draw arrows or shade it. Okay, so a conjunction, I'm talking about any number in between the negative 4 and the 6. So if you look at problems number 7 and 8, those are also a conjunction. So let's try 7 and 8. I want you again to work them on your own and graph them, and we'll talk about them in class tomorrow. The last example is a disjunction, which is an or statement. Here I'm going to solve it as two separate equations. So if I look at number 6, I'm going to subtract 7 from both sides. It gives me x is less than a negative 3. And here I'm going to subtract 7 from both sides. And it gives me negative x is less than negative 6. Again, I'm going to divide this one by a negative 1. So I end up with x is greater than 6. Remember, I'm changing my inequality. And then I'm going to go ahead and graph it. So here I have the 0, I have negative 3, and a positive 6. They will both be open circles. But here I have x is less than negative 3. So my arrow will go to the left. And here I have x is greater than 6, and my arrow will go to the right. I want you to attempt to do problem number 9 following that example. And then if you highlight the very end sentence that says disjunctions are never written as one statement, they will start out and end up as two separate inequalities with an or in between. So I want y'all to practice those notes, and we'll finish the assignment in class.